This is a counting technique question from the 2008 Extension 1 HSC paper. It's worth 2 marks, which implies that the solution must be straightforward. The question states, Barbara and John and 6 other people go through a doorway one at a time. In how many ways can the 8 people go through the doorway if John goes through the doorway after Barbara with no one in between? If you think about this, you'll see that Barbara and John are sort of attached to each other, with Barbara first, John following straight through. So we could treat Barbara and John as a single person. And if you can see it that way, then hopefully you can see that for the first person to go through, we have 7 options, and then 6, 5, and so on. So the answer to this problem would be 7 factorial. If you can't see that straight away, then you can draw a pattern diagram to try to figure out what the answer is. And how I would do that would be to, let's start sending Barbara through, and straight after Barbara, John must go through, so we don't have any choice about that. And then there are 6 people left, and then there are 5 people left, 4, and so on. So that would be 6 factorial. The alternative is that someone goes through first, not Barbara, which means therefore not John. So we have 6 choices for that. And then Barbara goes in, followed by John, which leaves me with 5, 4, and so on. So that's another 6 factorial. Then the alternative is Barbara is the 3rd person. John must be after Barbara. So 6, 5, 4, and so on. And if you follow that, you'll find that there's a total of 7 of these, which ends up giving me the same answer. So you can see that by just doing a pattern very quickly, you could end up with the answer without, if you can't see the solution straight away. Part 2 states that we want to find the number of ways in which the 8 people can go through the doorway if John goes through the doorway after Barbara. This time around, there could be other people going in between them. Now, coming up with a pattern is still possible, but maybe a bit more time consuming. The easiest and the fastest way is to recognize that, well, when out of all the different ways people can go in, half the time John will be in front of Barbara, and the other half Barbara will be in front of John. If Barbara is not in front of John, then John's in front of Barbara, well, obviously. So the total possible ways of people going through the door is 8 factorial way, but we're looking at half of that. What if you can't see that? Well, let's do a pattern. Let's, just as before, send Barbara in. Now in this case, John can go at any time through the door. So really, for the next person to go in, I have 7 choices, 6 choices, 5 choices, and so on. So that's 7 factorial. The alternative is for Barbara to go in as a 2nd person. Now John can't go before Barbara, so I only have 6 choices. But now John can go in, so I have 6 choices, 5 choices, and so on. So that's 6 times 6 factorial. Barbara could go in 3rd. Again, John can't go before Barbara, so that's 2 people taken out. So that leaves me with 6 times 5. But now John can go in any spot, so I have 5 people left because 3 have gone in already, times 4 times, so that's 6 times 5 times 5 factorial. And you can follow this pattern through, and what you'll find when you total these up and you add them up, that the answer ends up being the same as 8 factorial over 2. So there are 2 approaches to most of these problems. One will be a faster way, but the other one a visual way, which will lead to the correct answer.